Okay, so it's 12 o'clock, so we'll get started. Welcome along to another Paramics workshop session. Thank you so much for joining us today. You may have been at the previous ones over the last 2 weeks, and so welcome back. If you're here for the first time, you're of course very welcome as well. And the sessions that we did over the last 2 weeks, we have recordings of them now, which are posted on our YouTube channel and support center. So please, when you get the time, go and check those out. So I'm very pleased today to introduce Neil Kay, who's going to be sharing with us today about collecting and presenting outputs from Paramics Discovery. Neil's a senior transport consultant with Sistra. He's a very experienced Paramics modeler, and he's been doing quite a lot of innovative work, particularly in the area of collecting outputs from Paramics Discovery. And he's going to be sharing some of that with you today. Neil was also instrumental in the select link analysis feature, which we introduced into the software recently. He played a key role in helping us with that. So just a couple of things about how the session is going to work. It'll last an hour. Neil will speak, I think, for about 40 minutes, something like that. So there's going to be time for Q&A at the end. We've got a chat function in Livestorm here, so please feel free to chat throughout the session as we go through. And there's also a questions tab as well. So please post questions as we go through. If anything comes up, we'll either hold on to the questions until the end, or we might I might interrupt Neil if the question is pertinent for that particular moment of the presentation. And the other thing is, you're really welcome to join us on the video and audio. It's always nice to hear other voices. So if you do want to share your own experience or a comment when we get to the end of the session, then please let us know, and we'll be happy to invite you into the video and audio and hear from you as well. Okay, so I think without any further ado, I'll just hand over to Neil, who's going to take us through collecting and presenting outputs from Paramics Discovery.
Right, so there. Okay, so good afternoon. As Malcolm said, I'm Neil Kay. I've got quite a lot of experience in Paramics. So it's basically broken into two parts. The first part focuses on the things that are built into Paramics and what the Paramics itself can show. And the second part is sort of more it's more expansive, and it shows what you can do using Python the Python programming language and GIS software. And the good thing about those two things is they're both free, so that's what's really good about them. I'm obviously aware that a lot of you have got different levels of experience, but Paramics can export data as CSV files and as SQL-like database files. CSV files, they're obviously very easy to open in Microsoft Excel, and SQL-like files, not quite as easy to use, but they make storing and querying data from multiple runs very easy, and it reduces storage requirements as well compared with the CSV. You can export data as CSV using export statistics, which I'll show you shortly. And it might be a good idea to download a program that can actually open up the SQL-like files, just so you can examine what's actually there. And actually, I use a program called DB Browser, which makes things quite easy to open it up, and then you can do your own SQL queries if you've got experience of that, or you can download as a CSV straight from the database file. So you can have a look at that. We get the output from the simulate. We generate output by using the simulate tab it allows multiple configurations to be set up, and you can choose different things that you want to run. You can choose different demand sets and choose which files to collect for different purposes. This is how we do it. This has obviously been sped up, this little movie. But there you've got 4 configurations there. They've got different purposes. You can run the AM, PM. There's a configuration there for the base matrix estimation. If you have any experience of that, it obviously collects the picture files that are very useful for that. So there you see it down there in the bottom right. Picture trips there has been ticked, and then I've got one with the vehicle routes file there circled. And the vehicle routes file we'll explore a bit further later on, which has got some really useful features in it. So when you're running a model, it's a good idea to use a simulation manager. It enables you to close the current model down, and models will run in the background when you're doing other things. And if you have any experience of using Paramics, sometimes you'll find that models can gridlock. You end up with lots and lots of vehicles on them, and we don't want to include those in the analysis. So you make a note of the gridlock runs, and then you remove them from your analysis. And if I just go back here, you'll see that the simulation manager is activated by clicking this button here, the running man. Whereas if you click that one there to the left, it just runs the models directly within Paramics, which is not ideal if you're wanting to close the model down. So we use the analyze tab. We've got the link counts. We can collect the link counts, turn counts, and other outputs. They can be shown in data plots. And we can export these things to Google Earth, and we can export them from a data plot, or we can use the other features. And we've also got the select link analysis, which we'll describe shortly. So I'm going to show you how to export statistics using the traditional tool there. It's very easy to use. We can specify which runs you want to include, as I've shown there, and we can specify the intervals. If desired. I've sped this up, so it actually takes a bit longer than in reality. And then we can move on to data plots. These are obtained from the SQLite databases, similar to the exporting statistics as I just showed you. And plots can be exported as a CSV, as I've said. So this is a model of Perth, which is a city in Scotland. And I'll just show you how to analyse things using the data plots. So there's the file there. We pick our database and we pick what we're interested in this case, link counts. And we can specify a different interval, and then I'm zooming in. And then you've got the value shown there, for example, if I just pause that. So the value shown here are 139 vehicles and some at 58.5 vehicles. And then I'm renaming it up there. And then I can export it as a CSV if desired. Obviously, you can do that from within the export statistics tab. And there I've got another one for turn counts, and I can show them both at the same time if desired. You can actually put data plots from multiple models into the same into the same analysis. So what you do is you copy one SQLite database from one model, and then you copy it into the location of another, which I'll just show you. So I've got one database here that I want to copy into another model, which I'll just show you. So I've renamed it there, and I'm putting it into another model there. So we've already got, so I'll just pause it, and then so I've already got one plot shown here, Perth CTLR closed. CTLR is a new road that's going to get built. It's effectively a path bypass. It's going to get built shortly. So what I've done is I copied another database from the CTLR open model, and I've copied it into that location so we can see the effect on flows. So I've created one there. Then I'm selecting that database file. And then you see them all there. So that's the value shown there. And then you can add another plot, which actually shows the difference between these two models. So I select that, and then I select the original data plot. And then you see the values there. So I've subtracted this number from this number, and then I get minus 22.5. So that's potentially really useful as well. So another thing we can do is we can export all that to Google Earth. It's a really simple feature. We've created our data plot. So we just go back to the original data plot that we created. And we just close that down. So we've set the data plot up, and then all we do is all I did there was I just right-clicked on the screen and just said export to 3D map, and then it loads up Google Earth. If you've obviously got that installed on your machine. Again, it's free, so there's no harm in it. So you see the values there. They're actually shown as columns sticking up from the ground. And you can see them all there. So that's potentially quite a useful feature. And obviously that's something, because it's all free software, you could set that up, and then you could send that to a client if desired, and they could look at it themselves using their own Google Earth. Select link analysis is a really useful feature. One downside is it involves the vehicle routes file, which are absolutely enormous when they're in database format or in CSV. And the journey times between links can be shown as well. So if you ever use the journey paths feature, what you need to do is you need to specify every single link between two points, and it'll show you the journey time between the 2 points. But because every single link has to be specified, there's a potential weakness in that it might not pick up a lot of the important trips. So I'll show you how it's done here. So select link analysis. It's picked from within the analyze tab. Just another menu item there. So I've clicked add, and then I've renamed it to the select link. I could have renamed it to anything. And I pick my 2 points. Then click analyze, and it shows you all the values there. So you'll see that between these 2 points, if I just you see between those 2 points, most of the vehicles using the segregated left turn on this roundabout, and a tiny fraction are using the normal roundabout, which is about what you'd expect in reality. But that's one of the advantages with using the select link, in that it shows you every single route that's available. And here, this is very complicated, so you maybe don't need to reflect on that, but you can actually export all this as a CSV, which I'll just show you shortly. And then I've got the trip matrix there. So that shows you the matrix of all the trips to and from the different points. So I'm just about to export them there. Select the folder, and open the folder there. And then there's a whole lot of different files that you can explore. There's one there. It shows you the duration between the 2 points using the different zones. The cost, the generalized cost between the 2 points, and the number of trips. So this is a really useful feature. Need to put that movie in twice. So as I've shown you, the journey times between the 2 chosen links, or you can use more than one. You can use 1, 2, or more links, and they're shown in all the exported outputs. And as I've said, that there's 2 big advantages with using over journey paths. You don't need to specify the paths in advance, so you can run the model, and as long as you've got the vehicle routes file there, you can just specify everything that you want after the model's been run. Whereas with journey paths, you need to specify the exact paths that you're interested in before the model's run. And the other advantage, as I've said, is that all the routes are extracted, not just those along the exact path. So if you've got more than one plausible route, or there's a lot of rat running in your model, the vehicle routes file will actually show that, and I think that's very useful information, and it's a very useful tool. And I'll show you later on, you can use the vehicle routes file, and you can use Python to extract more information from it to put it into QGIS, and it looks very effective. So that's basically the first part. I'm now going to show you the other ways of presenting the output, and this is more involved. You need to know the ins and outs of GIS software. I use QGIS, but obviously there's other software like ArcGIS, which is probably a more advanced version it's a more advanced GIS tool. But the problem is it costs quite a bit of money, and QGIS is free. And if you use Python, you can do things in Python that are more advanced than just using Excel. The other thing we can do is we can use video editing software and video collection software. And again, these are the free tools. There are paid for tools, which are probably a bit better, but there's free things out there. I use a program called Shortcut for editing movies, and it works pretty well. So why present data in other ways? Most of the data that we collect in transport modelling or transport planning in general has got a space element. So it's the number of vehicles, for example, that travel down a particular road, or the number of pedestrians that travelled along a particular area. So all of this is space data, and GIS software is really useful for showing that. And you can present a lot of data at any one time, and it tends to be potentially a lot more effective showing all this at one time. It can make things a lot easier. For example, I'll show you later on presenting queues within GIS software, and I think it's more effective than showing them as graphs. And there's a feature in QGIS called the temporal controller, which allows you to show features through time as well as space. So it's basically just showing you're able to collect little movies, and it looks really effective. And I'm sure there'll be something in that called in ArcGIS, but I don't have much experience with that. One of the advantages of collecting video output, the big advantage with that is that Paramics has always been designed for showing little vehicles on a network. It's an advantage of microsimulation over something like Saturn, which doesn't show things like that. And nowadays, you've got a lot of, as I said, you've got a lot of high quality video editing tools and video collection tools, and a lot of it's free now. Probably if we went back 10 years, you'd probably have to pay a lot of money to get something as good as Shortcut. So there's that now. So QGIS, it's a fully featured GIS package. It works with all the major file formats that you can think of. So for example, CSV, KML that Google Earth uses, shape files that are the traditional file that you get out of ArcGIS. And you've got map info tab files, which is probably less used, but it's there. And there's lots of other things. And by all accounts, by everything I've read, it's not quite as feature rich, but a bit more buggy than ArcGIS. But it's really good. I use it a lot, and it's free, which is a big advantage. So that's what QGIS looks like if you've never used it. This is bringing in the Perth model into QGIS in CSV format, and there's a lot of things here which you can use. to be honest, I rarely click on these things, but it's all there, and there's a lot of things. You bring it in, bring files into the software using the layer tab, and there's lots of different things. And as I've shown you, there's a background map using OpenStreetMap, which are brought in there. And that's great for showing in diagrams, as long as you remember to put in a copyright notice somewhere on the diagram. You can put those into reports and that. It's very good. Python, it's a programming language. It's well suited to working with the CSV files that Paramics outputs, and it's also very effective for the SQL-like files. You can directly manipulate, read from, and write to the SQL-like files if you desire. So obviously there's lots of other programming languages, but Python tends to be very commonly used because of all these features. You can write and run scripts within a feature within QGIS, but obviously you can use it externally. I use a little program called PyCharm, which makes things quite easy to use. But it's really, you can read and write things in a lot of different bits of software. One of the advantages with writing little scripts is that you can make things a lot easier than Excel. You've got lots of different calculations to do. Excel can kind of get bogged down, and it runs really quickly. And another advantage is that if someone's already written a script, you don't need as much. You don't need any real knowledge to actually run that script. You just need to know what inputs the script takes and what outputs it gives you, and you don't need to necessarily know what it's actually doing. So I'm going to show you a sort of study. I'm not going to take you through how the script actually did it. It's obviously a bit, too much detail for this presentation. But I'm going to show you. So this case study is a Crosstie Link Road. So it's that new bypass, and it shows you the different routing that vehicles will actually use once the bypass is in place. So that's what the situation is. So right now, using the black roads, traffic coming from here has to drive all the way through Perth to get to the A94 or A93, and it's a bit of a lot of congestion is caused by that. It's not very useful. When the CTLR goes in, which is shown in green, it will. These are little residential roads, but when it's built, traffic will be able to go along like that and travel to the A94 and A93. So it's a really useful road. So one of the problems, as I've said, with the vehicle routes file is it's absolutely massive. The vehicle route CSV file from one particular run is 250 megabytes, and it's about 3 million rows of data. And the SQLite files, which are easier to work with, they are a little smaller than that, but you've obviously still got a lot of data to process. And it's not, and I don't think it would be possible, or it would be very, very unwieldy to actually try and use Excel to process those files. It's just, you have to use CSV file splitter. It's just a mess. I wouldn't attempt it. So the Python script, however, it was able to crunch all the numbers, and it was able to directly export it as a new CSV file that could be imported into QGIS. And this shows the routing after. So you've got the current situation. It's shown in red, where you've got a lot of vehicles traveling that way. They go over a bridge here, and they travel up there. And what you'll notice is that there's a lot of rat running, shown in the sort of light pink lines. So some of it's going down the M90 and winding its way along there, and the others are going up the A9, traveling down there. So it's a bit of a mess. There's a lot of rat running. And when the CTLR is open, traffic just goes up the turns left along the roundabout, travels up the A9 and onto the CTLR and away up the A94. So it just gets totally away from the Perth town centre. So it's a really useful road. And this is something that you can. It's hard to actually show from within the sort of traditional outputs. But when you get to collect your own CSV file, it makes things a lot easier. So this is more in the select link analysis. Yep, so already been there. So as long as you collect the vehicle routes SQL-like file, you can form all the sort of traditional things that JourneyPass can do and more. This is another little feature that you can do within Python. It can show the journey times between selected points. I think this is a really effective little feature, actually. So what this is going to show you is the journey times to the A94 northbound from every other location within the model where there's at least a number of trips. And this shows you the journey times hitting this point here. So for example, here, this is showing that it takes approximately 36 to 42 minutes to go from here to here. And similarly, to go from here, it takes about 15 to 20 minutes or so. So it's not giving the exact times, but showing you the examples of how long it takes to go from the different locations when the CTLR is closed up to the N4 northbound. I think it looks like a really nice diagram, I think. I'm going to show you the next one. This is when the CTLR is open. And I think that pretty much tells the story. So we've gone from about 36 to 42 minutes. We go from here up to the N4 northbound, and it now takes about 15 to 20 minutes or so. So I think that tells the story. It's really effective. So I've got another case study. It's the town of Didcot. So there's going to be a lot of development that's proposed to be built. There's a lot of queuing within the model, so there's been a lot of queue paths being set up within the model, but it's not clear. Some of these paths, if you've got any experience of running a model, some of the paths aren't very interesting. There's not a lot of queuing in any scenario. It's maybe not worthwhile presenting by itself in Excel diagrams. Or you can present a lot of tables, and again, there's a lot of numbers in the tables, perhaps not very effective to present all that information. The important stuff can get hidden in the noise, hidden in a lot of noise. But you can present queues within QGIS. You can actually show these as a traditional output from Paramics, but the advantage of QGIS is that you can show background mapping and legends and things like that. So it's a really effective thing. So I created a little script for working out the exact geometry of the queue paths, and it shows them over every 5 minutes. So there was two models of Didcot. There was actually loads, but these are ones without the development and ones with. And the length of the queue is actually an accurate reflection of the length of the queue in reality. And within QGIS, I was able to play around with it, and I was able to increase the width of the bars shown, increased in proportion to the length. So which I'll show you. So here, well, first of all, there's a little legend here. Perhaps it's a little zoomed out a little too far, which shows you the area we're actually looking at and shown in pink. That's the time we're looking at. That's a legend. It's a little scale bar there, and as I mentioned before, there's a little copyright notice. So if you're putting that in a report, it's just a good idea to put that in, and it makes the things look a little more professional and prevents any potential legal issues. What we've got here is we've got the red and the blue bars to reflect the different models that are shown. So we've got blue for the do minimum and red for the with development. And there's not a lot of queuing right now between 10 to 7 and 5 to 7, but when I play this movie, we get this. I think it looks really nice. So you see that show you it again. I think it looks really good. So we've got the bars are building up here, and as you see that the width is increasing, certainly on this one, and the other ones, it makes the other less important queue routes that sort of disappear, and I think that's quite useful. And again, that's optional. We can do other things, but that's something we can all do. I think that's a really useful little tool. So this goes into a little bit of information about the Python script. We process all the queue data into a form that QGIS can input in a CSV file. And we use the temporal controller, which is a feature within QGIS, which allows the images from every time period, in this case 5 minutes, to be saved in PNG format. And you can then input that into some video editing software that has that feature, or you can upload it to a GIF making website to create the animation. I used a file called, a website called EasyGIF, and it works really well. And you can then create a QGIS print layout, which shows all the information like the legend and the inset map and the scale bar. And you can put that in, superimpose that on top of the little movie that you create. And you create the movie within a video editing software, and it works really well. And all of this is just using free software, so I think that's really useful. I've got another little case study. The client sought a way of showing congestion in a particular model of Glasgow, and one way of showing that is to find the ratio of the average speed to the speed limit on each model link, and we created a little movie like this. So as you see, red means that everything's really slow. So for example, if the speed limit was 70 miles an hour, that's saying it's going between 0 and 7 miles an hour, and blue means really quick. So you'll see in the first hour, which is shown up here in the top right, 7 o'clock and 8 o'clock, not a huge amount of congestion, but when we run the movie, it's a full 12 hours, I believe, and shows the congestion building up. Certainly in the PM period, it builds up really heavily. If I'll just show you again. So you see the red start building up when we hit the PM. And the good thing about this is it shows you a lot of information really quickly. It's not detailed information, but it is very important, descriptive, qualitative information. You can see how badly it's congested. So I see Joe's asked a question. I'll just get to just after I've finished this. So everything I did in the second part of the presentation involved Python and QGIS. I don't know what skills you have within the companies you work for, but it's a good idea for everyone to develop in-house skills with these tools. Certainly with GIS, you don't need a huge amount of knowledge of GIS software to get useful results from it. Somebody else, for example, can create a GIS file, and then you can open it, and then you can then interrogate that file to find the information you need. So it's really useful in that regard. Oh dear, it looks like there's a bit of an issue. Yeah, I've just got the bar here. It seems to be a bit of a mess. I would argue, sorry about that. I would argue that GIS software is a core tool for everyone that works in transport modelling or transport planning. I believe you would struggle to really get by without having knowledge of it. In the same way that Excel is a core tool, and I would say it's a really good idea to learn how to use it. And Python is a bit more bit more esoteric, but I would still say that's a good idea to learn at least some amount of skill with that software, so so you can develop your own little tools, because sometimes Excel just doesn't really cut it when you're working with large files. And it's certainly not very easy to make mistakes with Excel, because you have to remember how to do a process. So I think Python's a really useful tool as well. So, and that's it. So I'll now go to the questions. Right, the chat thing I'm looking at seems a bit juddy.
I can jump in, Neil, because I've been keeping an eye on the chat. And the question, really, just one question has come in so far from Joe, which was around on data plots, can the GEH outputs from the data plot be used for model calibration and the results presented in the model development report? So I've actually replied to him there, just saying yes, you can import survey data with it into the analyze tab, add it in as a data plot, and then compare that with a model's run or set of runs, and do the GH calculation within the analyze tab. So that's possible. Yeah.
To add to that, for another model I've actually worked on, I've actually done the GH calculations from within Excel, and then I've imported it into QGIS, and then you can show the labels. So basically the numbers and text, you can present that on you can present that within QGIS, and you can actually increase the size of the text font so that the bigger numbers are actually shown bigger, and it makes the sort of the bigger problems that you've got when you're actually trying to calibrate a model, it makes them stand out. So it's a really effective tool to actually do that. Yeah.
Yeah, great. So thanks, Neil, for the session. You've covered a lot there, and there's probably lots that people can dive into in more depth in their own time. I think really hopefully this session is a bit of a taster of all the different elements that are available, both within Paramics Discovery itself, and then also, as Neil has shown, some of the tools you can use sort of external to Paramics Discovery, but using those Paramics Discovery outputs to then develop useful presentations. I guess one of the kind of, just to sort of say, one of the ways that we're approaching this as software developers as well as modelers is that we recognize that Paramics Discovery is, it's primarily a micro simulation tool. It's about the vehicle simulation and getting those outputs. And so whilst we want to create some way of displaying outputs in the Analyze tab and also displaying vehicles in the Visualize tab, we also recognize we're not a GIS product and we're not Excel. And so rather than recreate those things within Paramics Discovery, we want to make it easier to access these tools, which are now really powerful. A lot of them are freely available as well, and therefore really get the most out of the outputs that you're able to extract from Paramics Discovery. So we've got another question coming in here from Joe. Will it be advisable to do the GH calculation from Excel using the statistics data export, as in data plot export? Can you field that one, Neil?
I would say it's a good idea to do the GH calculation from within Excel. I personally, when I'm working with it, is I'll get the survey data values, and then I'll put the modelled data values. I'll use VLOOKUPs and things like that to get the modelled data, and then I'll do the GH calculation from within Excel. And then that's not only useful within Excel, but as I say, I can export that into QGIS and then explore that in my own way.
Yeah. Okay, great. Thank you for that. I did popped a little poll in the up during the session, just to kind of get a feel for what people use so far within the analysis and presentation of results for the Paramics Discovery. So we got 14 votes back. 13 out of 14 use the data plots. So that's great to hear. Oh, we've got our 16 votes. Right, more people are adding their votes in as we speak, which is great. So we've got a high percentage using data plots and export statistics, which I guess are two of the main features within the Analyze tab. Then a few less, maybe about 50, just over 50% using the Simulation Manager. We've got 7 out of 16, so again about half, just under 50% using Select Link Analysis. So that's encouraging to see that the Select Link Analysis tool getting used by a significant number, and then fewer, not many, using the export to KNZ for Google Earth, and multiple model comparison as well. So hopefully this session has shown you a few of the different things available there if you haven't been aware of them, that you can then go and try them out and try and use them. What I'll also do during the remainder of this session is I'm going to post some links to YouTube videos, because we've got actually about 10 different YouTube videos relating to outputs, whether it's exporting to Google Earth, Select Link Analysis. We did work in version 24 around movie capture, so you can now get an MP4 file directly from Paramics Discovery capturing your movie, and various other things to do with analysis and data plots. So I'll drop those in the chat in a moment, so you can get those links. And while I do that, Neil, do you want to? There's another question coming in there from Joe. Maybe I could hand that one over to you.
I've got to be honest, I've not actually used the car parks feature. Do you mean like its own portals, Joe? Because I've never actually used. I'm not actually aware of what you're referring to.
Yeah. Okay. I can probably answer this one then. So I think what Joe's saying, yeah, pre-existing cars already parked in car parks are not shown when the model is initially run. Are they planning to include that in your next version release? So we're not planning in the next version release to do that. You're right that the pre-existing cars aren't shown there, and they only start to appear once cars start to park and then leave. So we're not planning that in the next release. We'll certainly take that on as feedback, and if there are others who are interested in that feature, then please let us know, and we'll weigh it up amongst the various other things that we're adding into the product. But thank you for that feedback. Okay, so please, we do have a little bit more time. I know it might be very sunny where you are. It's very lovely and sunny in Scotland today, and you might be wanting to get outside, but we're here for another 15 minutes. If you want to ask any questions in the chat, please do, and we'll be more than happy to answer. I'm just going to try and post some of these links here to the YouTube videos so you can see them. Wonder what will happen if I do that.
Okay, I see Brian's asked a question. How does a model handle comparisons, for example, link flows between non-identical models? That's a good question. I recall if anybody used Paramics a long time ago, there was a program called Data Analysis Tool. And I think if there was a non-identical model, it would actually ignore the links that weren't identical. So that's actually a good question. I'm not actually I think if they were non-identical, is that something you're aware of? If they were non-identical, will it actually show the values?
Yeah, I think it doesn't show the values between non-identical models. Yeah, so if you've got if the link has been realigned, well, it'll depend probably on the link names. So if it was just a realigned link, then it would be fine if the node names were the same. I think you would get the link flow between both, and it would compare them. If you're introducing new links or changing the structure of the network, which often is the case when you're looking at non-identical models, then you won't get that comparison. So you have to kind of plug those gaps, I guess. But in a lot of cases, I don't think it's so significant, because often, if it's a new scheme you're adding in, like a whole new road layout, then, well, it just doesn't exist in the base model. So there's actually nothing to compare the link flow against in the base model anyway. But all the link flows will, of course, be compared on the links that stay the same between the two models. I hope that makes sense, Brian, but if it's not clear, please come back and we can try and answer that again. So I'm going to try and post some of these videos here. It would be interesting to know in the chat if anyone has done anything similar to Neil, has used some of the GIS features, or maybe done things slightly differently. Then it'd be interesting to know what how things are being used, more widely, as well as just amongst us at Systra.
Yeah, as I was saying, one of the big advantages if once someone has developed a little script that can do something quite smart, other people can use it without necessarily having a detailed understanding about how it actually works. It's just like a formula within Excel. I don't know what Excel is doing when I do some complicated formula. I just know that it works, and I think that's what's really getting over. You just need to know what the inputs are and what the outputs are, and then you can get your own, and then everyone can use a really cool little feature.
Yeah. Okay, so I've just posted a bunch of YouTube videos in the chat that you can, you can click on the links to and find those. It goes into some of the things that Neil talked about in a little bit more depth and talks you through how to use some of them, and just hopefully really gives you more exposure to what is available in Paramics Discovery in the Analyze tab. You can also search them on the YouTube channel or even on the support center as well. Okay, thanks for the comment from BM, some useful tips. So question in from Matthew Moss: are the journey times between origins and destinations comparable between two models if there are more route choices in one model than the other?
Well, the answer is yes to that. If you build a new road that makes things a lot quicker between 2 points, then it's going to make things, then the journey times are directly comparable, yes.
Yeah, and I think this is where the select link analysis tool is very valuable, isn't it? Because what you're able to do with that is to pick a start and an end point, and you can capture all the different routes between that origin and destination. And that's of course slightly different to coding journey paths, where you're defining a specific path that you want to capture the journey times on. So another real useful purpose for select link analysis, I think, in capturing that.
Yeah.
Okay, so here we go. There's another question coming in from Joe. Can the modeled journey time be affected if the on-street parking feature in the model is applied, and the survey journey routes when validating the model.
I'm not really sure how to answer that, to be honest. Again, the on-street parking feature is not something I've used, unfortunately.
Yeah, I'm just taking a minute to get my head around the question as well. I think what we can say about the on-street parking feature is that it does model accurately the slowing down and the parking maneuver of the vehicles. And so what you will get, particularly if you've got a congested network and lots of traffic, is you'll get a slowing down and the kind of knock-on effect on subsequent vehicles from that. And then as the vehicle moves into the parking space, you might have a queue forming. The same when the vehicle's pulling out as well. It will affect any traffic on the network at the time. So the parking feature does have an impact on the rest of the traffic on the network. It's all linked. They're responsive to the behavior. And so in that sense, it can affect the journey times on that particular route. Now, I'm not quite sure I'm understanding the question fully, but I guess when it comes to calibrating and validating a model, what we really want to be doing is we want to try to reflect what's on street as best as we can. And if what's happening on street is parking maneuvers or other types of delay as a result of parking, and that is reflected in the model, then that would be an absolutely suitable way to model that particular area and be part of the calibration and validation of that model. Yeah, I hope I've answered that, but if not, Joe, please let us know.
I haven't used the on-street parking feature, as I say, but I have run a model where on-street parking was a major issue that had to be dealt with. And I modeled it. I tried to model that by putting in pretend traffic signals. So vehicles would basically stop for the pretend traffic signals at random, and then it was to simulate the effect of having a vehicle reverse parking into a space, for example. So yeah, it was a major thing, and I had to carefully calibrate that to get the correct journey times along the road.
Yes, yeah, and that's still a valid approach. Like, I think when it comes to modeling, we've always got to make those judgments about how much detail we can model or need to model, and how much we might use other methods to kind of create the same effect, essentially. But certainly now with the parking feature there, it's another option. It's another way to create some appropriate delay that can result from parking. Okay, so I don't see any other questions coming in. If you do have any, then now's the chance, because we're probably now getting close to wrapping up, I think. So just in case there are any others coming in, I'll just to remind you that we've got our final session of these workshops next week. Again, it's on Tuesday at 12 o'clock. And that session is going to be about software news. So we'll be looking back at the last year about what we've done in Paramics Discovery over the last year, and also then looking forward to the next couple of years and what we're planning. We will have Dave Bennett here next week. He is our software development manager, and I know at workshops I've been to in the past, everyone really appreciates Dave's presence, because he's able to really explain a lot of the detail of how Paramics works in a way that myself and some of the modelers don't understand. So it's be great to have Dave with us next week, and He'll also be doing some demonstrations of some of the new features he and his team have been working on since version 24 was released last year. So that's what we're going to be focusing on next week. What I'm going to do as a kind of final thing in the chat is just drop in a link to that session for next week, and I'll just do that right now as I'm talking. And if you haven't signed up for that yet, then you can just click on the link right now and join in that session. So I'll just drop that in. Okay, so I don't see any other questions or chat coming in. So I think that just leaves me to say a big thank you to Neil for presenting today. I've appreciated you sharing different things you've been working on with outputs from Paramics Discovery. I hope that's been useful for everyone, that it gives you a few threads that you can follow up and explore a bit more about what we can do with outputs from Paramics Discovery. And thank you so much for joining us today. We really appreciate it. And we hope that that was useful and interesting for you. And hopefully we'll see you all next week.
Yeah, thank you.
Bye for now.
Bye.